Okay, we're going to try and connect some chapter 1 stuff with what we're doing here. You may get a question like this. It says, write the quadratic function, they left out a word, that goes through these 3 points, negative 2, 32, 1, 5, 3, 17. And this is kind of how we're going to do it, okay? So we're going to use matrices, and this is the standard form of our function. And it's nice because it gives us a few things that we can work with. It gives us 1, 2, 3 places to find, or 3 things to find, but we have 3 points, and so we can do it. So I'm going to set up the matrix and show you what it looks like. So we'll first write it out as the equations. So I have my 3 equations. I have 3 unknowns, A, B, and C. And we are going to use this as our matrix. So here I have my coefficient matrix, my variable matrix, because I'm trying to solve for the variables A, B, and C. And I have my constant matrix. If I wrote it as an augmented matrix, there would just be a line here. And then I'd have 32, 5, and 17. Okay. So what I have here is Desmos. We're going to use that in a second. But first, we're going to remember how we use an augmented matrix, or excuse me, a coefficient matrix to solve. So here I just named, this is matrix A, matrix B, and matrix C. Matrix A is a 3 by 3, matrix B is a 3 by 1, and matrix C is a 3 by 1. And to solve for B, I need to take the inverse to both sides. These matrices will cancel out, and I will have matrix B equals the inverse of matrix A, essentially times matrix C, okay? And then I will get A, B, and C equals, I'll get some matrix here, okay? So I'm gonna open a web browser. I'm gonna type in desmos.com. Use this on your Chromebook. So before you click on anything, go up to here where it says Math Tools. Drop down menu, you have all these math tools. We're going to use Matrix Calculator, and I'm going to show you how to input the matrix. So we're going to use a new matrix. It's not a 2 by 2. We have 3 rows and 3 columns for matrix A. And in that was 4, negative 2, 1, 1, 1, 1, 9, 3, 1. And I'm going to hit enter. That's the return here. I have a new matrix. The other matrix was B. That's what we're solving for. And it equaled my coefficient matrix. It's just going to assign it. Actually, let's see if we can change the name. Let's clear that. Let's go C. No, it's just going to automatically do new matrix. We can just input this as C. Can we change that? It's not letting us change it. Well, there are 3 rows, but only 1 column. This is going to be our constant matrix. So 32. 32. Why isn't it letting me type it in? Yikes. Okay. New matrix, 3 rows, 1 column. 32, 5, 17. Oops, that's not 17, it's 27. Enter. Now, I need matrix A. I need the inverse of it, and look, it automatically does it. Just fractions if you want. Times, pardon me, matrix B, boom, it automatically spits out the answer, 3, negative 6, 8. So going back to we have 3, negative 6, 8. That means that A is 3, B is negative 6, and C is 8. And I need to write the equation in standard form. It's going to be y equals 3x squared minus 6x plus C. Because remember, this is our A, this is B, and this is C, just like we find them here. So here we have Esteban. He's training for discus. His coach is recording the horizontal distance, so I'm not sure you're familiar with, this is my guy. This is Esteban. He's throwing this metal heavy composite frisbee. And when he throws it, it's going to travel in an arc or a parabola, and then it's going to hit the ground somewhere. What they're saying is the coach is recording the distance. Actually, it's from the stop. And then at some distance, it'll be at some certain height. Okay, and so, for example, our first point at 1 meter, it is right here at 1 meter away and 1.75 meters high off the ground. And it's going to continue. It's got all these points along the way. Okay, but we don't have an equation, so we're going to use a tool, technology. So we can use a graphing calculator. There's a way to do this. We can show you that later. Right now we're going to use Desmos. So I am going to go here, open up Desmos, and we are going to figure this out. So let me type desmos.com. I'm going to go there. And what we need to do is we're going to go to graphing calculator right there in the middle. And here it's just, I can input stuff. What I want to add is a table because all I have is a table of values. And then I'm going to input my table of values. So I have my table of values. And then here's the points for each of those table of values. Oh, wait, hold on. So, yeah, so those are my points. Okay, all right. What I need to do now is I need to click on this 2 here, and I need to actually type in the equation I want. So I'm going to hit Y, the number 1. It automatically does that. Hold Shift on the tilde button, which is up there next to the number 1. Remember, our standard form is ax squared plus bx. Oops, I forgot something. So if you look at the table, it's x1, y1. I didn't put an x1, so I need x1. Boom. And then, boom, right there. See, it already started to plot the points. Plus c. So the computer is trying to find a quadratic equation that will fit for these points that I input. It's trying to extrapolate and find the equation. And here it is. Here's the a, here's b, and here's c. And there's some points that they highlight here. So if you look at this gray dot right there, that is the vertex. So 19.413 meters away, it's 10.994 meters high. Here, it's at 0, so he's holding it, and it's 0.659 meters off the ground. So it's in his hand as he's spinning around. That's the y-intercept. X value is 0. The x-intercept is negative 0.609. That's the x-coordinate, and the height is 0. But that doesn't make sense in the context of this problem. What does make sense is this other one here. That's the other x-intercept at 39.434 meters away. The height is 0. That means the discus has hit the ground. So this is the x value that when we plug into this equation here, we get a 0 here. Okay? So this is going to be our standard. We're going to use A, B, and C to write our standard form. So I'm going to write it. Our y equals negative, I'm going to round some of these, 0.027 x squared plus 1.058x plus 0.672. And this is what we can use to predict. So we can find out how high it is when it's a certain distance away. And what you do is you just replace x because this is the distance from Esteban. And this is the height off the ground.